Hey folks, welcome to today's lesson. Today we're focusing on some solutions for the 2011 paper. I think it was a term 3 paper for functions. So I'm just checking some of the questions out of that function section. So for part A, it's asking us to sketch the diagram and then state the domain and the range for each of these functions. I'm not going to spend too much time on this. The first function we're looking at is y is equal to x squared minus 6x. I've just expanded that to make it a little bit more reasonable for us, which hopefully we recognize is going to be a parabola. Now, in terms of the parabola, we have to be a bit more descriptive. I guess we need to have the y-intercept for this, the x-intercept. We need to have the axis of symmetry, and we also need to know what the turning point is, and that's more to have a nice sketch, but more for the domain and the range. The y-intercept, we can hopefully see, well, that's plus 0. Okay, we've got the x-intercepts there. Well, we know already that up on the actual question, we'll give it in the form of y is equal to x brackets x minus 6. It's already been factorized, so we're just going to let the y equal 0. So 0 equals, and then we've got x outside of x take away 6, which means x is equal to 0 and x is equal to positive 6. Now, so straight away I'm going to put my x-intercepts there, 1, 2, 3, 4, 5, and 6. I'm going to put it there. So I can see my x-intercepts, and obviously that's the y-intercept as well. And clearly that means that the axis of symmetry is at the point 3, because that's halfway between 6 and 0. If you're not sure of that, we can use the negative b over 2a, which in this case would be negative 6 over 2 times 1 is 2, which equals positive 3 anyway. And we need to have that value, of course, so we can sub it in to find our turning point. So y is equal to, I'm going to use this formula here, 3 squared, which is 9, take away 6 times 3 is 18, and 9 take away 18 is negative 9. So I'm going to put negative 9 down here and put my coordinate, and then I can do my, oh, that's pretty ugly, isn't it? I can do my sketch. Here, I might do this in green, and then goes through 6. That's a little bit nicer. So I've got my graph there. So I've sketched that. That's pretty much all I need to do. For my domain, of course, we're going to have all real x values. And for my range, we're going to have y must be greater than or equal to negative 9. Okay, hopefully I'm going to run out of room most likely here. So that's for the first one. For part 2, hopefully we recognize that that's the graph of a semicircle. So I'm going to do a straight sketch of my semicircle here. If I square root 36, we get 6, which means that my semicircle has a radius of 6. That means we go out to negative 6 to positive 6, and we go up 6 or possibly down depending on what we're looking at. Now this is a positive square root, which means that we're doing the semicircle above the x-axis, which means my semicircle is there. That's pretty much all I need for my graph. For my domain, we can see that x must be sitting in between negative 6 and positive 6. Again, that's because we can see clearly here that's where my x values are going to be. My y values we can see are between 0 and positive 6. So my range, we get y must be greater than or equal to 0 and less than or equal to 6. Okay, hopefully we got that part. Number 3, we have got, hopefully again, we recognize that's going to be a negative, which is unfortunate, makes it more challenging, but a negative hyperbola because the x is the denominator. So the most important part here is we need to know where the asymptote lies. The asymptote, hopefully we know that is x equals negative 3, because that means that minus 3 plus 3 is 0. We can't divide by 0, which means that's where the line's going to be, where I'm not going to have any x values. I'm going to do that in maybe a yellow color so it's clear to see. That's where my line goes. You can see it there. Now usually that's pretty much all I do, and I draw my hyperbola as you can see there. However, because it's a negative parabola, it means that it's going to go the opposite direction. So like that and like that. Okay, so it's a little bit unusual, I guess. Now for my domain, we're going to have all real x, but x cannot equal -3. I'm going to have for my range all real y, x there, root y, but y cannot equal 0 in that case. Alrighty, again, these are just my exam questions, so if you need to have any further lessons, please go back and have a look at how to sketch those graphs. The last one, we have an absolute value graph of y equals x take away 2. The most important part is where it bounces. Okay, we want to let this thing be 0, so that means that x is equal to 2. That's where it's going to bounce. So 1 and 2. So it's just a nice graph. There's no plus numbers there, so that's where it's bouncing. So it's sort of looking like this. I've got my x-intercepts labeled. My y-intercept can be seen. Oh, hold on. And my x-intercept is going to be +2. Now again, you might think it's -2, but remember this thing needs to be positive when it's an absolute value, so it's going to bounce at 2. And again, I can check that by subbing in the 0. 0 take away 2 is -2, and the absolute value is +2. That's where I get that intercept. So again, that's the important features for that particular graph. My domain, in this case, is all real x, just like a linear graph, but my range, y must be greater than or equal to +2 in that particular case. Alrighty, that's the first set of questions for part A. Part B, which is quite a challenging question, it's going to be the first part for 2 marks is going to cause the most grief. So it's asking us to sketch the function for -4 to +4. So I'm going to start by doing my x and my y axis. Again, this is going to be a bit difficult because it's only a small part of the screen, but hopefully it makes a little bit of sense. And this is a really challenging question. 1, 2, 3, and 4. Basically what it's asking us to do is to sketch these 3 graphs onto the same axes. Now usually we've had that before, you know, you might look at the intercepts, the point of intersection, those type of things, but this case we're not going to be drawing the whole graph. For example, if I was asked to draw the graph of f of x equals -2, that means the same as y is equal to -2. Hopefully you might remember that that would be the graph of y equals -2. It's all the way across there. Now that would be the graph of just y equals -2. And I do need to draw that graph. The problem is I only want to have the values for x is less than or equal to -1, which means I actually only want it from that point forward, which means that I'd have to delete that section of the line. So just so it looks nice on the screen, and it's not going to allow me to do it, unfortunately. It might delete it afterwards. Let's wait and see. Okay, hopefully that's worked. Sorry, it's a bit stop-starty there. Okay, so I'm just going to draw the graph from y equals -2, but I'm only going to draw it just to -1. There. Okay, so I only want it from those 2 points. Now, the next graph, so that was the graph of y equals -2. I'm now going to draw the graph of y equals x plus 1. So where would that go? Well, looking like we normally do with linear graph, we know that the y-intercept is at +1, at x plus 1, sorry. It's at +1, so I'm going to put 1, 2, and 3, which means that my y-intercept here is at +1. Again, it's because we find x equals 0, y equals 1. And if I want to find my x-intercept, we could chuck in 0 where the y is, x plus 1, which means it's going to be at -1. And so generally we would then draw the graph the whole way through. The only issue is I want my graph between -1 and between 2. So this is what I'm going to do. It's going to be a little bit hard here because I've done something that's going to be a bit tough. Okay, I'm going to draw my graph. So I'm going to draw it from this point. I'm just going to do a hollow dot, because see how it's not actually equal to -1. So I'm going to draw it all the way through. That's my next part. but I need to throw it through up into less than 2. So I need to figure out what point that's going to be. So 2 plus 1 is 3. So I'm going to put a nice little hollow dot there, and it goes all the way through. So it's kind of that same line, but noticing I have to have hollow dots because it can't equal to 2. Then for the last part, we need to draw a parabola. Okay, so which is y equals x squared plus 1, which means it's going to be sort of a parabola that kind of looks like this, kind of like that. But again, we only want it from greater than or equal to 2, which again is a bit challenging. So I guess what I'm going to do for this part, I'm actually going to do a table of values for my parabola, and I'm just going to do for 2, 3, and 4, as I've got my x values there, and see what happens. So 2 squared is 4 plus 1 is 5, 3 squared is 9 plus 1 is 10, 4 squared is 16 plus 1 is 17. I don't have those values on my graph, which is a bit tough, but that's okay. So I've got 2 and 5, which would be about here, and then it goes up. So again, it's a bit hard to see. I probably need to have a bigger axis here. So that's part of my parabola, okay? And the parabola would go obviously like that. So again, it's probably not particularly too accurate there, so I do apologize. But it's called a discontinuous graph. You're actually drawing just sections of 3 different graphs, and you can see why that's quite challenging. Okay, so part 2 is the easy bit. It says to find the function of -1 plus the function of 2. So first of all, I'm going to look at where -1 will go. -1 goes in that first function, which means that the y value is simply -2. There's nowhere where I can chuck in the -1. There's no x value, so that's just my answer. For function of 2, okay, where does 2 go? Well, 2 is greater than or equal to 2, which means it's x squared plus 1. So I'm going to chuck in the 2 where the x squared is plus 1, so that's 4 plus 1 is 5. So that's the value of f of 2. And what does it tell me to do with those two functions? It says it wants me to add those two functions together. So -2 plus 5 is equal to 3, and 3 is my answer. Okay, and the last one says to write an expression for the function of a squared plus 2. So although this is worth 1 mark, this is a pretty tough question, because I guess we all know that we need to substitute a squared plus 2 in for the x's, but the problem is we've got 3 functions. Which function do we choose? Do we choose all of them or just one? Well, just like these two, okay, it's a number. Now notice here that your number, for whatever a is going to be, if it's a negative number or positive number, your number always has to be greater than 2. For example, if I chuck in -1, because it's a squared makes it positive 1, 1 plus 2 is 3. I'd put it into this function here. If it's a positive number, or 0 even, 0 squared plus 2 is 2, I still put in this function. If I had 1, 1 squared plus 1 is 1, plus 2 is 3, I still put in this function here. So actually this is the function that we're subbing into for number 3. Okay, so if I sub it into the function of x squared plus 1 for where the x is, so that's what I'm putting in, we're going to have a squared plus 2 all squared plus 1. So I square it, I get a to the 4 plus 2 times a squared, double it is 4a squared plus 4 plus 1, which gives me a to the 4 plus 4a squared plus 5. And for 1 mark, I reckon that's pretty tough. Okay, alrighty. So that's part B. Part C, show that this is either odd, even, or neither. So we've got f of x is equal to -2x minus 6x squared. Now I need to compare x and the negative x, because remember my rules that if it's even, we know that f of x is equal to f of negative x, and if it's odd, we know that f of negative x, when I sub it in, is going to equal the negative f of x. And if it's neither of those two, we know it's neither. So let's sub it in and see what happens. -2 brackets minus x minus 6 brackets minus x squared. If I simplify that, we get positive 2x, and then we get minus 6x squared. Okay, Now obviously looking at that, that does not equal the top function, so it can't be even. So I'm going to cross that one out. So if I want to look at this and see if it's a negative function, well, let's take a negative out, and then I'm left with minus 2x plus 6x squared, which again is not what I've got in here. Okay, it is different, therefore this is neither odd or even. Okay, so again though, I've kind of shown that's the fact. Alrighty, next question and last question. We got part D, which says sketch the function. This is a really weird function. It's not just like a normal one, I guess. It looks much more challenging. So what we need to do, we're going to factorize the top part and make it x plus 3. And we're going to divide it by x, because what we're going to actually do is to find if there is a point of discontinuity. So what we're going to look at here is divide the x's there. We get y is equal to x plus 3. Now for this case, the limit, you can see x cannot equal 0. So we're going to say the limit as x approaches 0. And then if I want to find the limit of, or the point of discontinuity, we're going to sub in that 0, because you know that's what it can't be in the original question, into here. I'm going to say as x approaches 0, the limit of the question y will equal 3. That's going to be my point of discontinuity. So it takes me a while to spell that. Now, okay, so if I graph this, now what's my function going to look like? Because remember, this is a pretty hard function, but actually it's the same function as y equals x plus 3, which is just a straight line, which means I've got a y-intercept of 3. If I chuck in the 0 and rearrange it, we take it away, we get minus 3 for my x value, x coordinate should I say, or my x-intercept. I'm going to sketch my line, as you can see there, of y equals x plus 3. But remember, this isn't the graph of y equals x plus 3, because there is a point of discontinuity at when y is equal to 3. So 0, 3, that is where that line or that point of discontinuity exists. Therefore, it goes, oops, that's pretty terrible. It goes to the right of it, like that, and it goes to the left of that point, and that is my graph just as is. Apologies guys, that's taken about 17 or 18 minutes, so I do apologize, but that's certainly the section for the functions 2011. There are some tough questions there, but I hope this was useful to you. Have an awesome day guys, and let me know if you have any problems.